my recording also. Sometimes I forget to do that, but okay.
I believe they'd be equal.
Okay, how'd you do it?
Well, I picked 100 and figure a quarter of that would be $25. So he'd had 75 left, which would be a third of 75 is another $25. So he has $50 left. He spent 50 and he has 50 left.
So they're equal?
Yes.
Correct. Okay, and picking numbers is easily the best way to go there, I think.
I just don't seem to have my head in this today.
Okay, again, let's try to figure out, in other words, if in 8 years she'll be 3 times as old as she is now, just start picking numbers and let's figure out if we can figure out how old she is now.
Well, I just figured if she's 8 years old now, she'll be 24. Well, in 8 years, she will be 3 times as old as she is now.
So 8 doesn't work because in 8 years she'd be 16, and 16 is not 3 times 8. So what number do we need to pick, higher or lower? In other words, this is kind of like back solving. Pick another age for her.
24 now? I don't know.
Go down. She's not 8 years old now because in 8 years she wouldn't be 3 times as old as she is now. So try a smaller number. Just pick a smaller number, any smaller number.
2.
Okay. If she's 2 now, in 8 years she'll be 10. That's 5 times older. So we went too small. Somewhere between 2 and 8.
Well, we can go with 5.
Okay, if you pick 5. The problem with picking an odd number is that if you pick an odd number and you add 8 to it, it's still odd.
Okay, so 4 would have been.
Okay, that's what I'm trying to get you. In other words, I'm wanting you to just start picking numbers. If 8 didn't work and 2 didn't work, then pick 4. Or pick 5 even. But 4 works perfect. In 8 years, she'll be 12. That's 3 times older than 4.
Okay.
Okay, so that's the first part of the problem. Tiffany is 4 years old. Now the rest is easy. The number of years until Tiffany will be 6 times as old as she is now. And we're comparing that with the number 16. So what's the most logical first step at this point?
Well, she'll be 6 times as old as she is now. We would multiply 6 times 4.
No, Now, the next logical step would be to figure out what happens in 16 years.
Okay, and she would be 20.
Okay. In other words, we're trying to figure out whether this number here is less than 16, equal to 16, or greater than 16. So the first one we'll try is 16. Maybe it's exactly equal. If she's 4 years old now, in 16 years she'll be 20 years old, but that's only 5 times older than she is now.
Right, okay.
So obviously we need a number greater than 16 here.
Okay.
Okay, in other words, in 20 years, she'll be 24 years old, which is 6 times. So this number here is 20. And all of these are basically trial and error. It's got to be the way to go on these. Because it's so easy to do the arithmetic when you start picking numbers. What I see on your part is a reluctance to pick the numbers.
Yeah.
Just pick a number and go with it and see whether that works. In other words, the first number you picked was 8. That didn't work. And then if you pick 10, it goes in the same wrong direction. So you know you got to pick smaller. You pick 2. That was too much. Got to go up. And these numbers, this is a good problem, a really good problem. Because we kind of had to back solve to get Tiffany's age. And then you got to know what the next step is to compare these two. And that next step is to try 16, first of all. Because 16, if that's quantity A, if it's 16, it'll be apparent immediately. In other words, if 16 years from now Tiffany was exactly 6 times older than she is now, then you could immediately say quantity A is equal to quantity B. And if it's not, we'll know whether this needs to be a bigger number or a smaller number. So it's very, very much like back solving.
Okay.
Now, this one is tricky, particularly tricky. Let's look at this algebraically.
Okay.
What's the algebraics? Well, this is a word problem. So what's the first thing we need to do?
Define the variable.
Okay. Let's do it.
Well, we have X equals the 4-cent stamps.
The number of 4-cent stamps. And I'm picky that way because I think it's very important to know precisely what X is. It's not just X is 4-cent stamps. It's the number of 4-cent stamps that she put on that envelope.
Okay.
And Y is 7-cent stamps. Now, you definitely want to use 2 variables here because we have no immediate way of relating X to Y. It's not like I could say Y is 50 minus X. I can't do that. So I have to look at this problem as a problem with 2 variables. And now, what equation can I write from the stem here?
0.04x plus 0.07y equals 50. 0.50.
Okay, let's eliminate the decimals altogether.
Okay. So 4x plus 7y equals 50.
You see why that's better?
Yes.
Rather than leaving everything in dollars. I mean, if one of these was in cents and one of them was in dollars, we're going to have to make the adjustment. But since everything's in cents, let's just leave everything in whole numbers.
Okay.
Okay, so this is our equation. And we don't have another equation. So we can't solve for x and y. The only other equation we have is that this has to be an integer solution. In other words, when I have one equation and two unknowns, I have an infinite number of solutions. But if I insist that x and y have to be integers, then I have a very finite number of solutions. X can be somewhere between 0 or 1 and 10. Y can be somewhere between 1 and we can even put limits on it. Okay, so how we go from here is not that clear. Even the book gets to this point and they say there's an infinite number of solutions, but the only two integer solutions are x equals this, y equals this, or x equal this, y equal this. So at this point, assuming time is not an issue, if time is an issue, I don't know what you do. But let's start going through some possible solutions here. And that's the only way I know to do it.
Okay.
Okay, now we do have some constraints. We know that y can't be more than 7. You see why?
Yes.
Okay, and x can't be more than what?
12.
Can't even be 12. Notice that if it was 12, this would be 48, and there would be no possible integer y. So can it be 11? No, because that would be 44, and still there's no y that works. Can it be 10? No. In other words, that's the way we have to do this problem.
Okay.
Can x be 9?
Yes.
Ah, there's one integer solution. X is 9, y is 2. Now let's just start counting down. Can x be 8?
No.
Can x be 7?
No.
6? Now let's stop for a moment. Let's make sure you're doing this right. If I'm testing whether x can be 6, well, that would have to be 24, which means this would be 26. Is 26 divisible by 7?
No.
That's the logic we want to go through.
Yeah, that's...
Okay, good. So can x be 5?
No.
4?
No.
3?
No.
2?
Yes.
Okay, so x can be 2, and what is y?
6.
Okay, and we could test x, could it be 1, and it can't be 1. So we've come up with these are the only two solutions, and it wasn't that difficult. It took, what, a minute?
Yeah, not long.
Yeah, so it wasn't too bad. And problems like this, I don't know of an algebraic way to solve it, to be honest. There probably is one, but I don't know how to do it. But as long as we're dealing with numbers like 50 and these numbers, it wasn't that hard to go through it. And this immediately tells us, excuse me.
Bless you.
Excuse
Bless
me.
you.
Thank you. So the moment I get a second solution, I know that I can't tell. And in fact, the moment I find out that there's these two solutions, I can't tell, and I don't have to do any more testing. In other words, I could have avoided testing to see whether x was equal to 1, because even if x was equal to 1, it doesn't change anything. It means you can't tell. The moment we get an x equal 9 or an x equal 2, it's impossible to tell which one.
Okay.
Even if there are more integer solutions, we don't care. Okay?
Okay.
All right. Last problem before we're on to geometry. What should I do to solve this problem? What's the first thing I should do?
I don't know.
Draw a picture.
Okay.
Okay? Car A is going north. Car B is going east. After 9 hours, how far has car A gone?
360 miles.
How far has car B gone?
180 miles.
30 times 9.
Sorry, 270.
270. Okay, and they want the distance from car A to car B, so they want the hypotenuse of this triangle. Aha, we got the geometry before we thought we were going to. So, at this point, let's cross off a 0 and see if that can be 45. Now,
And yes, because it's a 345.
good. How did you recognize that it was a 345? I'm sitting here trying to figure out how to recognize that that's a 345. You divide 90 into everything, huh?
Yes.
Yeah, if you divide 90 into this, you get 3, 4, 5. So the moment we realize that is 45 or 450, we're done. They're equal to one another.
Okay.
Okay? All right. Let's see here. Lines and angles. Their geometry sections are lines and angles, and then triangles, and then circles, and then quadrilaterals, pretty much, are the 4 remaining sections. Let me see if I can blow this up a little bit, because you need to see it a little better. There. In the figure below, what's the average, meaning the arithmetic mean, of the measures of the 5 angles? This is 2A, 3A, 4A, 5A, 6A.
Okay, so B2A plus 3A plus 4A plus 5A plus 6A equals 360.
Okay. Conceptually, can you find the shortcut here? So we know you know how to do it the normal way, which is to add up all the angles, divide by 6. Excuse me, divide, yeah. Oh, no, there's only 5 of these, aren't there? Yeah.
Yes.
But conceptually, what's the short way, the way they want you to solve this? Think about it for a moment. if I have 5 angles that total 360 degrees, that's all I need to know.
So 360 divided by the 5 angles?
72. In other words, it doesn't matter what these angles are. If I take a circle and split it up into 5 or 11 or 14 different angles, I don't need to know anything about those angles. I know the average is the number of angles divided into 360.
Okay.
Okay? In other words, they're trying to trap us with all these numbers here. This could become a big, complicated problem if we try to figure out that arithmetic mean the normal way. What do we have? We have 20a divided by 5. So the average angle would be 4a. And we know that 20a has to equal 360, so we can solve for a. A is 18 times 4, 72. That's the real long way to do it.
Okay.
Okay? And we had a question like that on the test. In fact, I think both tests have that question on it. So this is a principle they like. Okay. Now this one's real hard to see, but I can describe it easy enough. There are 1, 2, 3, 4, 5, 6 equal angles above the horizontal line. Each of those is A. And there is 1, 2, 3, 4, 5 angles equal below the horizontal line. Each of those is B. So they want to know what B plus A divided by B minus A is.
Okay, and wouldn't all the angles equal, all the A's would equal 180, and wouldn't all the B equal 180?
Correct. So the process when you see a problem like this, or at least the process I went through, was, is there a shortcut? I couldn't see it at all, and the book didn't indicate there was one. So the first step you want to say is, I don't see a shortcut, which means I've got to solve for B and I've got to solve for A and then answer this question. Unlike the previous problem. In this problem here, there's no need to solve for A if you spot the shortcut. You just know that the average of those 5 angles has to be 360 divided by 5. This is a totally different problem. We do need to solve for A and B here. So how do we solve for A? You said it already.
Yeah, 6A equals 180, so 180 divided by 6.
Okay.
So A equals 30.
Okay. What about B?
And B equals 36.
Now it's a piece of cake.
Okay.
66 divided by 6 equals 11. And I guess as long as you can solve for A and B easily, and you were able to, don't spend too much time looking for that shortcut.
Okay.
Because there isn't one here, and you have to solve it. So even on the previous problem, it wouldn't have been that bad to solve it the normal way if you didn't see the shortcut. Maybe an extra 20 or 30 seconds worth of work. But okay.
Just a guess, but would it be, well, no, that wouldn't work. 2x plus 3y minus the 90-degree angle
Okay.
equals 180.
Okay, so 2x plus 3y equals 90.
But then I have nowhere to go from here.
Okay, consider the most obvious way to finish the problem from here. Back solve,
Oh,
right?
yes.
Should be a piece of cake to back solve it.
Okay, so we started with 27
And you know 27 can't be right because,
because,
oh, excuse me, no, I don't know that. Well, you'd know that y would have to be 63. And is 63 to 27 a 3 to 2 relationship? No.
no.
Okay. You know it can't be 45 because that'd be 45-45, which is a 1-to-1 relationship. So what must the answer be without even doing any more math?
Okay, you just went too fast for me. I got lost. Okay, it can't be 27 because that wouldn't be a 2 to 3 relationship.
Right.
It can't be 45 because that would be 90 right there with the x.
Right.
So it has to be less.
It has to be less than 45, and it has to be more than 27.
Okay, so yeah, 36.
Okay. Now let's go back to the 27. Why couldn't it be 27? Well, because that would make y, you can do that in your head fairly easily. And is all, we know that that's not a 3 to 2 relationship. 63 to 27 is a 2 to 1, more than a 2 to 1.
Right.
So I know x has to be bigger than 27. And if I try 45, it's too big. I know it's got to be smaller than 45. I'm done. The answer is 36. Now, there is the algebraic way of solving this. Once I get 2x plus 3y equals 90, well, I also know that y over x is equal to 3 over 2. So there's my second equation. And now I can solve for x and y based on 2 equations and 2 unknowns. But I still think the easier way to do it is to back solve it. The moment you find out that 2x plus 3y equals 90.
Okay.
Now, it's real easy to take the next step of back solving it rather than writing out that second equation and solving 2 equations and 2 unknowns. Because the back solving works so easy from this point forward. Always have back solving in the back of your mind as a way to go if you don't know how to proceed.
Okay.
Always check back solving. I check it every single time I have a problem that I have doubts about.
Okay, well, the first thing I do on this one is draw the clock.
Okay. Now, don't waste too much time drawing the clock.
Okay.
You don't want to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All those numbers are immaterial. We do need 1.
And then 50.
50 would be the 11. But the big hand's not really on 1. It's between 1 and 2. So here, let me erase the 1, put a dotted line to there. And let me make this the solid line. So we need this angle right here. Let's break it up into pieces. What's the angle between 11 and 12?
$30.
What's the angle between 12 and 1?
Also $30.
What's the angle between the 1 and the big hand of the clock? In other words, what's this angle right here?
Well, it's not going to be quite 30.
Excuse me, I made a mistake here, first of all. 1150 goes to 10, right? Yeah. So we need this 30-degree angle also. It's less than 30, correct? How much, what part of 30 is it?
I'm going to say about 20.
Well, we can't approximate because we have to put a precise answer down here. If the big hand is at 10, then how far how far has the little hand moved from 1 to 2, what fractional part, as the big hand is on 10? How far around the circle has the big hand moved? What fraction?
I don't know because it's not quite on the 1 or the 2.
Right. But the big hand, not the little hand, but the big hand has moved all the way around to the 10, which means it's moved 5/6 of the distance that it has to go. In other words, the little hand won't be on the 2 until the big hand moves another 1/6 of the circle. So the distance of the little hand has to be 5/6 of the distance from 1 to 2. And what's 5/6 of 30 degrees?
You know what, I'm not quite sure. I don't understand this one.
Okay, that's fine. Every time the big hand, there's the little hand. Here's the big hand. Every time the big hand makes a full revolution of the clock, the little hand moves 30 degrees.
Okay.
So if the big hand were to make, pointing down towards 6, where would the little hand be? It would only move halfway between 1 and 2, making this angle 15 degrees, right?
Okay.
In other words, whatever percentage of the circle the big hand has moved, the little hand moves that same percentage between two adjacent numbers. So if the big hand moves all the way around, then the little hand moves completely from the number 1 to the number 2. If the big hand only moves halfway around the clock, the little hand is halfway between 1 and 2. Well, the big hand has moved 5/6 of the way between around the clock, right? It's not gone all the way around. It's only to the number 10. It would have to get to the number 12 to move all the way around.
Okay.
So it's only going 5/6 of the way around the circle, which means the little hand has to go 5/6 of that 30-degree angle. Well, 5/6 of the 30-degree angle works out to a nice round 25 degrees. And so this is 25 degrees, and now the total angle is 30 plus 30 plus 30 plus 25. I like this problem. I've never seen this problem before on a math test where they ask you for the angle between at a certain time. but it's a clever problem.
I would never have gotten it.
Okay, at this point, do you understand?
I think I do.
Okay. Okay, let me give you a test. If it was 145 instead of 150, the time. In other words, let's say that the big hand is pointing at the 9 on the clock.
Okay, so it would be 9/12
of
the hand between 1 and 2.
which is a 30-degree angle. In other
Correct.
words, once you figure out that it's always 30 degrees between two numbers, now we want 9/12 of 30 degrees. So that angle would be 30 plus 30 plus 30 plus 30 plus 9/12 of 30. Which is not a whole number, but it's okay. Doesn't need to be.
No, at least I understood how to do it.
Well, it sounds like you do. You just did it on this one.
Yeah, thank you, because seriously, if I would have seen that one on the test, I probably would have just finally guessed on it.
Okay. Well, that's fine. Okay. Guessing is going to be a lot harder when it's a fill-in-the-blank question.
I know, and that's why
The
I
guess
probably...
is almost certain to be wrong. It's
Exactly.
not like guessing on a multiple choice where you're going to have at least a 20% chance.
Well, yeah, and at least this way now, because the way you explained it does make sense.
Okay. Okay.
But yeah, if I would have actually had question number 5 on the test before you went over this, I probably would have just guessed and said, oh, 120 degrees.
Okay. So if it was 130, we'd count all of the 30-degree angles between here and here, and then we would take half of 30 for that last smaller angle. All right, let's go on. Part of these is seeing a new type of problem. Like I said, that's the first time I've seen that problem. But now that you've seen a clock problem, I got a feeling you could answer any clock problem. If I told you that it was 5:42, you could probably figure out the angle between them based on that.
Yes.
It's always going to be the same logic. So, and it's always going to be 30 degrees between each point on the clock.
So yes, I appreciate that.
Okay. All right. Concerning this, if angle A is equal to angle B, which of the following statements must be true?
Well, I would believe that C would equal D.
Okay, that's correct.
And let's see, L and K are parallel.
Okay. I want you to visually try to disprove that. And what I mean by that, it's hard for me to describe it online, unfortunately. In fact, even if we were in person, it would be hard for me to describe it. But it would be very easy for me to describe it if I had a bunch of sticks in this shape. Okay?
Okay.
If I had a bunch of sticks and I took line K and line N and held this angle right here fixed and rotate those two sticks. I don't care how much you rotate them. You can rotate them 1 degree or 2 degrees. You're rotating this line and this line, which are fixed relative to one another, but you're going to rotate them so that we no longer have what looks like a rectangle here.
Okay.
Notice that those lines would not be parallel.
No, they wouldn't.
Necessarily. In other words, I still got the same angle B. So even if I rotate these two lines by 5 degrees, angle A is still angle B because I'm not changing line N relative to line K. I'm changing these two lines relative to the other two lines. So kind of imagine picking up these two lines, don't change this angle at all, but pick them up and rotate them a little bit, and it's easy to see that K can no longer be parallel to N if it was in the first place, and yet A is still equal to B. So the fact that A is equal to B does not make these lines parallel.
Okay.
And it doesn't make line N parallel to line M either. Because notice that as I rotate K and N, I change any parallel relationship that might have been.
Right.
Okay. So they're not parallel. And M and L, are they perpendicular?
Well, once again, I think you could probably move the lines and keep that one spot.
Exactly. In other words, I could, in fact, is all I have to do is take lines L and K, pretend they're parallel, and rotate both of them together. That's going to keep, oh no, that wouldn't make A equal to B. Well, nothing said that L was perpendicular to M in the first place. In other words, the thought process that I want to go through in my mind here is if I rotate line M, then clearly A is not, they're not perpendicular, right?
Right.
Okay. But if I rotate line M to the right, I make A obtuse if it was perpendicular in the first place. Well, B could be obtuse also by rotating line N to the left. In other words, that if these were perpendicular in the first place and I make them non-perpendicular, can I still make B equal to A and do that? Sure, because I can certainly rotate line M to make A not 90 degrees, and it's relatively easy to rotate line N in a manner to make A equal to B. In other words, if I can rotate these things and still end up with an A equal to B, and clearly they're not perpendicular, then they're not perpendicular.
Okay.
They're not necessarily perpendicular. So the only statement that's always true is C is equal to D, and that's because they're both supplementary to the same angle.
Okay.
Since A is the same as B. Okay, this is A, B, C. And A is to B as 3 is to 5, and C is to B as 2 is to 1. What's the measure of the largest angle? Again, don't always think algebraically. This is a perfect back-solving problem. Why?
Well, because we know A, B, and C. Well, see, I'm going to say once again, though, the A, B, and C equal 180.
Okay, which they do. But the reason this is such a good back solving is what is the measure of the largest angle? Where are we going to start with our back solving? With 100.
Okay.
Always. In other words, if they said, what's the measure of the smallest angle? We're going to start with 30. You see why?
Yes.
Because if we were looking for the largest angle and I tried 30 and it didn't work, I'm going to have to try 45, I'm going to have to try 50, I'm going to have to try 90, and then I'll know. But since they want the measure of the largest angle, let's start with the largest angle and work our way backwards. So clearly B is the largest angle. So let's pretend B is 100. Now, and let's see if everything works. If B to C is a 2-to-1 relationship, immediately when we see that C is to B as 2 is to 1, then B is not the largest angle.
C is.
Right, they've drawn this not to scale. So C is equal to 100, not B, if we're back solving it.
Okay.
So what would that make B?
That would make B 50.
And A? All three of them total 180?
10?
All three of them?
Yeah. 30. 3 times the 10.
Okay. In other words, we're not going to use these relationships to figure out A. We're just going to subtract these two from 180.
Okay.
So if the largest angle is 100,
it works.
It works. We're done. And that's all we're trying to prove is this that 5 to 3 relationship or 3 to 5? And if 100 would not have worked, let's just see what happens. Make sure you see what happens if we pick the wrong answer. So it doesn't take too long from this to know that C has to be the biggest angle. Even if you start off thinking B is the biggest angle, you're immediately proven wrong as soon as you see that relationship there.
Okay.
Okay, so we know C would have to be 90. B would be what?
45.
And A would be what?
45. Yeah.
And
90, 45, 45.
Since that is not a 5 to 3 relationship.
Okay.
Okay. Now we wouldn't know which way to go. This is not one of those ones where when you back solve it and you pick a wrong answer and it doesn't work, it's not that easy to know whether we need to go bigger or smaller. But they've made the problem easier by saying what's the largest angle. So I'm just going to test all the large angles, starting with the biggest one. And again, I think they have purposefully made 100 be the correct answer. Why? Because they want to reward the people that are back solving and back solving it properly, as opposed to making 30 the largest angle. Then that would punish the people who are back solving it, because you would have to do 4. Notice that even if 30 is the largest angle, you don't have to test 5 scenarios. You only have to test 4.
Right.
You actually never have to test all 5. Most you could ever have to test in a back solving problem is 4, and usually it's 2 or less. Let's see, that's the last problem on this page. Go to the next page. Ah, good. It's clearer. Well, it sure makes a difference. That's the same camera. Same lighting. It's just I held it steadier here. All right, number 8. Let's see. I got to be careful here about going over. I have a 10 o'clock online also.
Okay. If you'd like to stop at this one, we can.
Let's do. I got time for this one. I'm pretty sure. Yeah. I just had to turn my camera off because my computer was complaining. Yeah, let's do this one. What's our first step on number 8?
This one I draw the points.
And B is somewhere in between A and C. We'll put B right there. Let M and N be the midpoints. So there's M, and there's N. If AB is to BC in a 3-to-1 ratio, what's the next step?
Let's see if AB, I don't know.
Pick numbers for these line segments. Pick a number for the length of AB and pick a number for the length of BC.
How about for AB we have 3 and BC is 1.
Okay. Now what is MB? Since M bisects AB.
It would be, let's see, MN?
No.
MD.
Well, first of all, let's figure out MB because it's easy. M bisects AB?
Yeah, 1.5.
Okay. And what's B?
So I guess I could have picked better numbers.
No, not really. This will work just fine.
Okay.
I mean, you could have picked 6 and 2, but that's okay.
And that'd be half.
Okay, so that's 0.5. So they want MN to BC. Well, let's just read it off. What's MN?
2.
What's BC?
1.
There's our answer.
Ah, okay.
So the fact that we ended up with decimals didn't really hurt us. It wasn't, didn't slow us down at all.
Okay.
So there's no real value in picking 6 and 2 here as opposed to 3 and 1. 3 and 1 works just fine.
Okay.
Okay?
Okay, thank you so much.
All right, Angela, and I will see you next. Oh, let's see. I think you made an appointment for next Thursday at 9:30?
Yes.
I moved that up to 9 again if you don't
Oh,
care.
good.
Yeah, I figured you wanted 9. So
Yes, that's right.
I had a note on there for next Thursday that prevented you from taking the 9 o'clock. I got to figure out a different way to do that. But
Okay.
okay, so I will see you next time. Is that Monday morning?
Yes.
Okay. Talk to you.
Okay.
Talk to you Monday morning.
All right. Bye-bye.
Bye bye.